I wanted to welcome everybody to today's DEWI Happy Hour. My name is Laura Duncan, and I'm president and owner of Gilslade International. And I sit on IDA's board of directors, and I am a co-chair along with Janae with Evergreen of DEWI. From my perspective, I've been doing this for a little while. I feel that the group is really meant to be your group, and that I'm just a facilitator of the ideas and desires of the group. And so I encourage all of you to voice your interests and your direction for the group, and I'll try to implement your ideas. As I said, there's nearly 80 people registered for today. If you want to put your name and company info in the chat, you can do so. We will send out an email afterwards with an Excel file that has everybody who had signed up for the session. I wanted to just get started with some quick business items before we jump into the panel discussion. I wanted to talk about the June IDA conference in Orlando. We will be having our regular DEWI forum that's on Monday, June 17th from 4 to 5 p.m. or 5:10 p.m. And it was I don't know, maybe about a year and a half ago, there was a suggestion to change the format of that forum to individual round tables so that there could be more small networking groups and make that time more valuable. In San Francisco at the February campus conference, we had nearly 50 people sign in, and there was about 200 women at the conference. So we had about a quarter of the women represented there at the DEWI meeting. My question for you today, and you can think about that, is that, do you want to continue with the idea of these tables and small networking groups? Or are you interested in doing kind of like a mixer game type forum? I'm open to suggestions. Right now, we have it set up that we're going to have those individual tables. But if you have some ideas or thoughts that you think might be better, please feel free to either message in the chat, or you can shoot me an email. We are going to be gathering during one of the dessert sessions as well. We've been doing that. That was an interest of just more opportunities for DEWI folks to get together and network. And Tanya's working on identifying which dessert during the conference will be kind of like a set aside for DEWI. And that actually, today's format is based on Ruthie with Tufts' suggestion. We are gathered during the dessert in San Francisco that she wanted or was interested in a non-technical district energy discussion led by women. And today we have a great group of women to share their knowledge with you, and there will be time at the end for a Q&A session. So if you do have questions, please put those into the chat, and then we'll address that at the end of the session. We do have another suggestion. If we like today's format, someone has brought up the idea of a panel to talk about decarbonization. So that could be a potential future session. And then, finally for me, the happy hour is, we've been really brainstorming new ideas, and we will be having a session once IDA releases the dates and information where they'll be accepting abstracts for presentations at the conference. We're going to have one of the happy hours centered around how to brainstorm your topics, how to write your submission for the abstract, and essentially support the women who haven't had an opportunity to present at the conferences. We really want to elevate that. We've seen a huge growth over the last few years of women participating. And so it's just kind of another outlet to share what that entails in that process. And so we'll be figuring out a day based on that. And so what I want to do now is pass it over to Janae, my co-chair, to talk about the LinkedIn page. Janae?
Good afternoon. Thank you all for being here. It's quite an honor to be in this room. I just want to make sure everyone is first and foremost already connected to the DEWI group on LinkedIn. I'll put a note in the chat, but if you search DEWI, DEWI on LinkedIn, you should be able to find the group. It is a private group, but you please sign up. You're welcome to join. And then we are always looking for profiles. So if you would like to learn, if you would like to share who you are, what your expertise is, and your experience in district energy, we'd be happy to do a monthly spotlight on you. So please just feel free to reach out to me. I'll put my email in the chat as well. Thank you so much, and thanks to our great presenters today.
Great. And so now I'd like to introduce Ruthie with Tufts. I'm going to pass it over to you. She's going to be moderating our kind of casual my brain just went dead there. Panel discussion. Right. Thanks. Sorry about that.
That's okay. Thank you so much. Welcome, everybody. So my name is Ruthie Bennett. I'm the Senior Director of Capital Programs at Tufts. And I'm really excited to have this conversation with some really intelligent and experienced women, hoping to learn a lot from them. So just quickly, Tufts, we actually have a central energy plant, and we distribute steam, electricity, and hot water to over 100 buildings on our campus. And we are working on a project to convert the steam to hot water for our decarbonization plan. So then I'm going to let the panelists introduce themselves, tell us who they are, a little bit about their work. Ximena, do you want to start?
Yeah, thank you, Ruth. So I'm actually kind of the newbie here. This is my first district energy project, but my name is Ximena Cruz. I work for Bond Brothers. I'm a project manager there, and I'm currently working at Smith College. We're doing a geothermal energy project here. So that's kind of how I got involved here. So I'm not an expert, but I definitely have learned a lot so far in the project. So I'm happy and excited to share with you guys.
Great, thank you. I think that's the key, that all of us are at different levels in our career and different levels of experience. And that is the point of these happy hours, is to learn from each other. You know, I think the panelists are really experienced and knowledgeable, but I also know we can all learn from each other and from folks in the webinar. So there's everybody's a beginner at some point. Elizabeth, do you want to introduce yourself?
Sure. I'm Elizabeth Nolder. I am a principal with RMF Engineering, civil engineer by trade. So spent the last 13 years specializing in underground thermal and electrical distribution. So just happy to be here and share any knowledge I can.
Great, thank you. Michele?
Hi, I'm Michele Bryant. I'm the plant engineer here at Austin Energy District Energy and Cooling downtown plants. I've been doing this work for 27 years, so I guess I'm an older, seasoned engineer, but I started out as a controls engineer and designed all kinds of different things as a controls engineer, and then I went to be a plant engineer, so kind of a pay raise.
Right. Great. Okay, I think that's our panel. So I'm going to start with some questions, and feel free to jump in. So when a client calls you, or an institution decides that they want to create a district energy system, or they want to change their existing district system to a different medium, like Tufts wants to change from steam to hot water, what should the client bring to you so you can get a handle on the scope of the project? So any thoughts on that? Kind of what happens in the beginning? What should folks bring to somebody to get started?
I can start. My thought on that was, first kind of what are the goals? Like, why do they want to switch to this different medium? You know, is it like cost and maintenance because, you know, steam is more expensive to maintain, or is it, you know, kind of a carbon neutral, which then, you know, will get you into a geothermal project. And then also I would say just like as much information as they can about their existing system, so that when we are looking to go into the new system or this new medium, that we understand what the current system is doing, so that, you know, for example, if you are going from a steam system that's currently picking up like, you know, your hot water and domestic hot water, that, you know, if you're going to a low temp maybe system, then maybe you need some individual water heaters because, you know, you have to supply like the right temperature for maybe like bathrooms or, you know, kitchens, sort of that. So just kind of getting all that information. And then I also think, you know, just like obviously their budget, their schedule. Of course, I'm working in, you know, a campus. It's always, you know, graduation and whatnot. So I think schedule is definitely a big part of it, and, you know, communicating with their stakeholders too. Just like, you know, this is what we are planning on doing, and this is the cost, maybe.
Great, thank you. Elizabeth, you want to add?
Yes, sure. So when she said information on existing system, as much information as you can. Like, I'm going to ask you any questions and you may or may not have answers to them, but how you currently operate, how you want to operate in the future, how you're going to transition from one to the other, or if it's going to be in phases, or if you're going to do a wholesale switch, because that'll impact some of the planning that goes into it, and the schedule as well. I think that those are the big ones. How you want to attack it and how the new and the old are going to play together are the big scope understanding.
Those are super important. I would also add phasing. Like, are you open to phasing? Can you only do this in the summertime on a campus, which would make this a very long project? So just kind of how does your institution operate from a timing point of view? So Michele, anything to add? If that.
So ours is a little bit different. So we have customers who want to attach onto our distribution system. So the first things that we do is say, okay, where are you? Are you close to our transmission line? Because that really does affect cost and our ability to get our pipeline to you. Where the mechanical room is, what kind of construction schedule do you need? Or, you know, when do you need that chill water? When can we put our skid of heat exchanger and instrumentation in that mechanical room? So we have to really ask a lot of questions. What pressure rating? How many stories of the building is? It all depends on how we design that heat exchanger system. And so it's, you know, lots of questions, pressures, temperatures, tonnage, you name it. We ask all the different questions, and then we go back and then we communicate with our design engineers to try to see if we can't do that as the most cost efficient way.
Right. Yeah, so I think those are really good answers, because if you think about it, there's kind of this high level of, like you said, Ximena, what is your goal? Like, why are you doing this, right? And then, you know, on what type of campus? Are you 24/7, 365? Do you slow down at a certain point? Are you connecting to an existing system? Are you trying to have two systems, like you said, Elizabeth, you know, talk to each other, work with each other? And then
you're in the same mechanical room.
Right. The mechanical room, where is that? You know, that'll have a big impact. And then Michele, you were talking about like nitty gritty, right? What's the pressure, right? Where can we put the skid that's gonna, you know, be the exchange between the distribution and the building? So it's multiple levels of answering that question when you want to start a project. And I guess the number one thing I think you all said, which is, you know, you're going to ask us a lot of questions. It'll be over and over. There won't be one like document where we have it all. It just doesn't work that way. So it's iterative in terms of the information. So my next question kind of follows up on that. When a client has a conceptual plan of where they want to lay their piping for a district energy project, what are the items that will ultimately cost them money if they don't uncover them or ask questions about them in the early stages? So basically, how can we avoid changes later? So what should they know, or what would you ask a client or an institution to help them, like sort of, not to use a pun, but sort of dig up those issues early on?
No, dig up is I'm going to jump in here, but dig up is the right word to use because it's anything underground. None of us, have X-ray vision. So it's always with the distribution systems, it's what you can't see that's going to come back to bite you. So we try to do as much upfront documentation as we can, go through whatever records you have that we can get our hands on, do surveying with utility locating, and then normally we recommend test pitting, like potholing, to verify exact locations of utilities we think we will be crossing in some way to make sure that we're not going to be in conflict with them. So
Can you describe test pitting? Like literally, what is that?
Sure. It's basically you take you can use either air or water to disturb the soil, to vacuum it up. It's like a big old shop vac, to take the soil out of the ground, to dig down until you find the top of the utility that you're looking for. So that way you can pinpoint it in horizontal and vertical space. So as you're developing the underground profiles, you're making sure to avoid anything that's already there. Because that's always the hardest part especially with piping that you're putting underground. If there's been a 6 to 8 week lead time to get it onto the site, and then there's a conflict in the way that you need a new fitting for, or a new piece of pipe, and now you're calling the manufacturer and begging them to rush ship you something so that you can still meet your schedule. So that getting as much information as you can about what's going on underground through whatever means are at your disposal is really.
Can you talk about when you said survey, right? Like, I assume it's not a person walking out there rolling the little thing to measure it out. What can you say what you mean by survey?
Sure. It's a topographic survey. They normally now use like a GPS kind of pole to locate surface conditions, whether that's contours, so you know what kind of elevation grade changes you have going on your site, or where the 30-inch trees are that you don't want to dig up because students will start throwing a giant fit about it on a campus, as well as utility structures, so water valves, manhole covers, anything you can see at the surface that can be documented. And then a utility survey, you can get either GPR, or actually some surveyors will tone out the utility hooking onto existing features so that you can trace out where the utilities are underground from above. It's not, there's always like a 18-inch or so wiggle room of error, but it gives you a better idea than nothing of what you're going to see when you open things up.
Right. Ximena or Michele, any thoughts on kind of what should clients think about in terms of their piping layout that's going to possibly cost them money later?
Yeah, definitely. I mean, I was going to say the same thing as Elizabeth just said, because not only is it, like time for you to stop the project because you uncovered something you weren't expecting. It's also going to be like downtime for the rest of the project. Like your subcontractors were ready to go and we need this at a certain time, and now it's kind of delaying that portion. And then something else would be maybe making sure the owner, thinking of a campus, of course, but just if you have like a 10 to 20-year plan, like this is what I envision of the campus, just because right now you're going to be doing all these distributions, you're installing all these lines like throughout your campus. And, you don't want to come like 3 years later and be telling us like, oh, actually now we need to reroute all of these pipes that we just put in place because we want a new dorm right here, and now everything's kind of in your way and you build it yourself, you kind of tripped yourself. So I would say maybe having kind of like that long-term vision right up front.
That's really important. Michele, did you want to add?
Yeah, so here, a well thought out plan, your drawings, your specifications, making sure that the contractor understands your requirements, because we get a lot of change orders because they do not understand what we have put in our specifications, and then we're requiring something more stringent. And so having those dynamic specifications where you plan and learn from past experiences to make them better for future projects. So making sure you're detailing what you are your lessons learned and apply those to the next phase of a project or even a new project. So keeping those lessons learned. I did a QLA and a QLB, which are survey quality levels, are at utmost important. If you don't want to have a change, we already know what we say. We tell our design engineers, just go from point A to point B, because we definitely know that it's going to be changed during construction, because we start digging and that utility is 5 feet where it was said in our Esri or some of our different areas. So just having that detailed plan and a backup plan, a contingency plan is super important.
Yeah, no, that's definitely true. So that question was about when you're starting the project, what about, piping layout? But my next one is about, you're going to put these pipes in the ground and you're going to own this system for a very long time. So what are the top items that institutions need to make choices on in the beginning of the project that will affect the schedule, price, and the longevity of the system, right? So they're going to own and maintain the system over time. How do you think about, what should you think about in the beginning of the project and the design to have that sort of schedule, price, and also longevity of the system in mind?
I can start with that one.
Yeah.
So for us, it's first understanding the specifications, making sure everybody understands what the outcome of that project is. The second is piping. What type of piping are you going to use? Certain pipe is a lot more expensive to other pipe, but does that pipe have to have a larger excavation envelope if you go from, say, your carbon steel pipe over to an HDPE pipe? Your bedding envelope is going to be much bigger in an HDPE pipe environment as opposed to steel, but the steel has a lot more welds and is not as convenient to push a welded pipe as it is, just lay in a HDPE pipe. So just
Michele,
understand what kind of pipe.
can you explain what HDPE pipe is?
Yeah, that's high density polyethylene pipe. It's plastic pipe. We call it plastic pipe.
Okay.
And it's flexible and bendy, and it's super easy to turn and lay in the ground, where carbon steel pipe is rigid and it's not bendy and it's not easy to lay in the ground.
Right. Yeah, it's definitely
Sorry
not
about that. I use these
no, that's okay.
everyday little abbreviations.
Yeah.
Instrumentation. We have found that using an industrial grade instrumentation is, even though it's more expensive in the at the upfront cost, but the long-term longevity and reliability outweighs the cost that we're going to have to do if we get, versus a commercial grade instrument or valve or anything like that. We have found that it's much better to use and spend a little extra money at the front end, and it gets paid back in those long ends, because we try to design things for a 50-year cycle and not just 10 years from now, oh, we'll get it. Because downtown, often you put it in the ground, it's there for a lifetime. And so we want to try to be good stewards of what's going in the ground.
Yeah.
And construction dates, knowing when construction is, when it ends, what is those anticipations?
It's great. Elizabeth?
Okay, so building off that kind of pipe type discussion, because that's going to be driven by your site conditions, by your operating conditions, if you have high water table, even a step further than that, evaluating if you want to have a pipe tunnel that provides easier, it is more expensive, it takes up more space under the ground, but it provides easier maintenance. In the long term, it's easier to replace sometimes depending on the tunnel. Same thing with a trench. There are definitely pluses and minuses to each of them, but that's even a more holistic view of kind of how you're operating your campus. Same with vaults. If you want to have direct buried valves, if you want to have valve vaults, how you're going to maintenance those valves, if you're going to allow your facility staff into confined spaces while the system's on or not. That's always gets into like a tricky situation. So what your campus requirements are that you're going to want to build in that kind of resiliency into it. Say also if how much space you're willing to give up at any one time, like if you're working in a summer construction schedule on a campus, or if you're going to let them have the whole calendar year, how much you're willing to bite off at any one time, and how much space you're going to let the contractor have for lay down or storing things on site, because that'll impact the price they're going to give you and how easy it is for them to get their job done.
Right. I mean, I think you mentioned a really important thing. So when we design a system at Tufts, a distribution system, we ask our facilities folks and our engineering folks to take a look at it, because we'll do the project of putting the pipe in the ground and the dirt comes back over it and you put the grass on and it's gone. But they have to maintain it. So they need shutoff valves. They need ways to know, where the pipe is located. All of that stuff, like you said, vaults or direct bury or all that kind of thing, it'll affect your price, but it also affects your maintenance over time. If it's harder for them to get to it, they're probably not going to get to it. They're going to let it, sort of deteriorate a little bit longer because they don't want to, that it's a confined space or that it's direct buried or whatever. So that kind of, how do you maintain these underground utilities over time is, I think, as you were saying, Michele, it's a long-term investment. It's an upfront cost, but it's over the long term, oftentimes will be valuable in the end. So let's move. Oh, sorry.
Actually, I was just going to give kind of like a example that I've obviously been doing construction for, I think it's like going to be 11 years now, but obviously this is like the actual first district energy project. So just kind of a lesson learned that I recently have, like I'm kind of focusing on the building side. So like once the, everything gets to the building conversion, that's kind of where I'm mostly focusing on. And something that I learned is usually the specs that we get might be, like this manufacturer or equal. But because this is a different project, it's not just like a building, you definitely have to coordinate and make sure that all of the buildings are going to have, if you didn't have a campus standard, that you're kind of being consistent in that, just thinking of the maintenance people that are now going to have like, oh, well, this toolkit for this maintenance, for this building, this other toolkit for the, you want to also, as you were saying, like involve your facilities people and think of what they're going to have to deal with after you get the system. So
exactly right. The upfront cost to have the facilities people be comfortable and able to maintain it is such a critical analysis. So I have a whole bunch of questions, but I'm going to focus on one because I know, Michele, you have some real great specific information to share with us. So what is the business case, whether it's financial or environmental, that would drive an institution to decide to install or upgrade a district energy system? And if you know of any federal, state, or local incentives to assist with the cost, clearly the Inflation Reduction Act is a huge incentive. But I know, Michele, you've done put together a couple of slides to help us understand how Austin Energy did this analysis. So I don't know if you're able to share those with us. Oh, perfect. It's all coming together. Super.
There we go. All right. So, 50% of your building's annual electrical load goes to air conditioning. And so,
wait, sorry, who's managing this? Oh, there we go. Thank you.
Yeah. And we can put it in slide, in slideshow mode. That'd be great. Right. Perfect. And go to the next slide. And so again, 50% of your building load is electrical, and it goes to air conditioning. And so if you can centralize that piece of the pie, then the building owner does not have to expend that electrical load. And so that helps the electrical utility, which we're also electrical utility. And it also helps them free up mechanical room space, have a green roof, or they can have a party roof. We have a lot of hotels that have party roofs. And so what we do is we provide that alternative. We put pipe in the underground, and we go and distribute chill water to these buildings, and all they have really much is some building pumps and a heat exchanger to segregate our water from their water. And pretty much that's all they have are pumps and some air handling units and the chill water coming from our system. So we take in on all the electrical onerous, and we're really efficient at doing that. And we try to make sure that we are using the least amount of electricity. So our kW per ton is that we try to drive it as low as possible. And then also we are environmental stewards. So our cooling towers, our blowdown rate is very small. And that's how much water you discharge out of your condenser water system, so that you can keep your evaporation and your system working as well as it needs to do. So it gets all those solids out as you evaporate water, all the little solid particulates get into the water stream. So anyway, we are environmental, we're electrical, we use very little chemical. We try to be, environmental stewards, not just with water usage, but also chemical usage. And being able to do that in a centralized location is really great. And so what a value that we have for Austin Energy is we're a load aggregate. So we're consolidating where the load, the main load is for Austin Energy, so they can define certain transformers for us, so they can provide electricity for more buildings in downtown rather than have to make new substations or new transformers. And we also do demand management. So we go and we do what we call load shifting, which I'll talk about in just a moment. So we can go to the next slide. Here is some downtown obstacles. So we do all our welding on site. And so the first that we have is our construction conflicts. So we have to get permitting in the right of way. It's really difficult to get permitting here in downtown Austin because everybody else wants to be in the street as well. And so trying to coordinate with all the new buildings coming in and trying to shut down streets to do construction is a challenge. And then what we have found, talking about that surveys just a minute ago with that question is when you try to do a survey and you try to do the potholing and they hit what we call CLSM, which is like a soft grout. I'm going to call it a soft grout or a soft concrete. And they can't go and define where those utility, because once it hits that concrete, their boring machine can no longer suck that soil out because it's not loose. And so then now we're stuck and we have no idea what's in the underground. So that makes design really difficult. And then again, utility locations, inaccurate or unknown utility locations. We've seen electrical duct banks not in the right spot. And then as we hand tunnel, we hit them. And then we have to go back and rethink how we're going to reroute our pipe and try to miss these utilities. And sometimes we have to go greater than 15 feet deep in order to miss these utilities. And so that costs a lot of money when we have to tunnel, because tunneling, as I said, can be expensive. It's time consuming. And there is also a hazard because we bury everything in pea gravel. And so when you're going up to an existing buried chill water line and it's in pea gravel, we don't want to cave in. So that's, a human life and safety. So we'll go to the next slide. The next slide is just some photos of our current construction projects we have right now. So the first one's just excavating the pit for the tunnel. Tunnel pits are enormous amount of size. This is a 25-foot by 35-foot excavation pit. Because they've got to get all of the equipment down to do the tunnel. The next one is actually the tunnel constructed. The next one you can see is where you can see our sandbags, where we had pea gravel at these existing valves. So we try to put sandbags at existing valves, so it prevents cave-ins, but sometimes we still get pea gravel escaping. And then down below, the first one on the left is a mechanical room penetration. So these are our pipes coming into the mechanical room along with our fiber conduits. And the next one is one of our welders welding the V31.1. It is a very stringent welding code, but it allows us to be ensure us that it is going to be there forever, and there's no imperfections in the weld. We also get them tested, each one of these in the underground, and then we use pre-insulated pipes so that our pipe stays nice and cold, because we push 32 to 36 degree water in our pipes. And the last picture is, you can see this is a trench, and it has our pre-insulated chill water pipes with our pea gravel. So it's just kind of some construction photos I thought would be nice for people to see what goes on when you're laying pipe in. And next slide, please. This is ERCOT. So ERCOT is our electrical reliability board that goes and defines, how much power is needed, and it says, okay, we need this much power from you, electrical utility, and we need this much power from another. This is just peak monthly demands. These are in megawatts. So that is, that peak was almost 85,000 megawatts of power here in Texas. So it's for all of Texas. And what we do is we load shifts. So we consume power during the low off-peak power consumption times. And then we turn all of our pumps off and just run on our ice tanks during that 3 p.m. to 6 p.m. window when we have high electrical usage. So we save the utility where they don't have to produce that kind of power. We typically use about 17 megawatts of power. And when we're on our ice tanks, we use 600 kilowatts. So it's a huge difference between the two. Next slide, please.
So Michele, I'm gonna ask you to kind of jump to this part, because I want to make sure we have time for Q&A. So
absolutely. So the benefits to the customer, it eliminates capital costs, because we're putting the piping in, and they don't have to have chillers or cooling towers or any techs that have to have that. It reclaims, and again, before I said, it reclaims the space, so they don't have to have cooling towers on the roof, and they don't have to have a chiller taking space, only just a heat exchanger. And again, it's financially attractive for standalone. It's reliable, simple. We save a lot of demand. We have a 24 megawatt shift of power. And what's really great is in the environment, by shifting those 24 megawatts, it's essentially saying we have taken 5,000 cars off the street. We have planted 1.1 million trees, and we're equivalent to 6,500 homes that are on the grid. So it's really beneficial to do that. And then the last one is our financial model. I'll get to that one. If you'll next screen. Our financial business model, again, it's a large initial capital cost for us, but we do get that back from the customers in our long-term 30-year contracts. And so we have to have is the heat exchange or the distribution pricing. We also allow in our contracts if they want to increase their capacity for their particular building. And then we also want to make sure we have ability to add new buildings. So when we do long-term analysis, what cost benefits and cost analysis do we do? And then again, our revenues, we do have 30-year term contracts, and we've just actually re-signed 2 of them. So that's really nice to see that we've been here for quite a while, and we're here for another 20, 30 years. And again, it's a positive return on our investments.
that's great. Thank you. So it's 4:42, and I'm just wondering if there are questions from anyone in the audience. I've got a bunch more questions, but I want to make sure in case people have specific things they want to ask us or something we said that they want to hear more about. I think you can put it in the chat, right? Tanya and Laura, that was the goal. They can write it in the chat.
The Q&A button is probably
Q&A. Thank you.
better, but either one, we can keep an eye on both.
Okay. So I'm going to keep going unless you tell me there are questions from the audience. Okay, so when you're thinking of creating a new district energy distribution system, what are the consultants that you're going to need? You know, the whole range. So I don't know, Elizabeth, I'll start with you. I mean, I know you're a consultant, but sort of who else, you know, would be on the team with you?
Sure. So we are a consultant. I am part of our civil team, but we actually have a lot of disciplines in-house who all tend to work together on a project like this. So mechanical engineers, electrical engineers, civil engineers, they're kind of all tied into these district energy systems because the energy is being produced and then distributed and then used. So you have kind of the generation and the end user, and then I am the in-between piece that's going underground. So those are standard, like we work on all of these jobs together. Sometimes you'll also need an architect if there's work going on in the buildings, a landscape architect, depending on what kind of area we are digging up to put this pipe in and how sensitive it is. If there's lots of trees, maybe an arborist. If there's environmental concerns with the soil or anything along those lines, that can lead to a geotechnical engineer. I think those are normally the ones that we tend to work on with our district energy projects.
Right.
Yeah, I was gonna say, I think I have almost everyone that you mentioned on our current project. One person that, you know, in my other projects, I was like getting to another project or just saw them kind of at the end, that it's been pretty interesting to kind of learn from them, is a commissioning team.
Yeah.
So just like bringing them, you know, early on, they first of all obviously have like a massive amount of experience. They've done like other projects like our project, and it's been really good to have them like from the get-go. They've also, you know, because they have the experience, they're able to, you know, give their feedback while, you know, the decisions are being made or things are happening during construction. And then obviously they're going to be doing the commissioning at the end. So it's, you know, I don't know if they're, I guess they're a consultant, but it's just been, you know, a really helpful tool in this one.
Yeah, no, I think that's a really good point, because the commissioning agent, if you bring them on early enough, they can tell you what they're looking for when they're going to commission, right? So you can work that into the design, as opposed to they come at the end and they're like, oh, you know, this is not going to work, and so we need to redo it and call the engineers to redraw, and you don't want to do that. You don't want to go backwards. So
Definitely.
The only one I would add is a traffic control engineering.
Yeah.
We have to have traffic control engineers.
Yep. So
As
we
well
have
as all the other ones you just said.
Yeah, we are putting a pipe in the ground this summer. It's our second summer of crossing a main thoroughfare next to our campus, and we need to submit a traffic plan to the city. They need to review it and approve it. And then you need a whole schedule of details, police details, when you're gonna like close the road or detour the road. And so, you know, once you actually get into construction, it's a lot of people helping make the project go smoothly. So let's talk about a contractor, right? So you're going to hire ultimately a contractor who's going to do all the work. So what kind of skills and experience should you look for in a contractor to do this specific type of work, the distribution piece, right? It comes from the plant that's generating. It's going to end up, you know, going inside a building or going, you know, just outside the building. What are the skills you're looking for? What's the knowledge that we want from a contractor?
I was gonna say as a contractor, but I definitely think, you know, experience is important. And you know, it's not like a building, it's a completely different type of construction. You're obviously affecting so many buildings. And once we do that, you know, cut off, like it's go time, you know, with a building conversion, there's no going back. Now everything has to be done, or you will have like no heat, especially, you know, in the winter for us. And also a word that we've used a lot in this project, which I really like, is partnership. So obviously, like, partnership between, like, you know, the contractor or CM with the owner, but also thinking, you know, when I'm thinking of contractors, also like involves our subs. And we, you know, have been using the word of partnership because yes, it is like, you know, a team, but it's also having them be involved because they also bring this tons of experience to the table, and kind of bring up like new ideas or things that they also can suggest, you know, even though, yes, we have like a design in place, like maybe they can, you know, have some opinions about it. And something really cool, at least you guys also mentioned that, with, you know, phasing, we've started in, you know, kind of the area where we're least impactful to like the, you know, everyday like core academic buildings, so that it's almost like a little trial run of this partnership where, you know, you kind of like iron out the kinks of like communication, just like CM to owner and OPM and with our subs. And so like, you know, phase one, you get all those lessons learned, and you kind of like iron out the QA/QC and things. And then you move on to, you know, a more critical area. And then, you know, for us, it's like 3 phases. So the third phase will be like, hopefully you're kind of like a well oiled machine by then as a team. And now this is like the most, you know, critical part of campus. But just like kind of inviting everyone to this like partnership where everyone is benefited from the project, and you're looking for, you know, the best project for them.
No, that's great. That's great. Elizabeth, do you have thoughts on that?
Yeah, so a couple things. First, experience in the setting that you're working on can be really important. Like Ximena just mentioned, working in the kind of the least impactful portion of campus, but having experience in a campus setting, it's definitely a unique situation with the students and all the events and everything that's going on at any given time. So having experience in the setting you're working on, I know it's a different animal for Michele in the city. So it's kind of, if you've worked in that before, you have that to bring to the table. Same thing, experience with whichever pipe type, like especially moving to like lower temperature, ambient loop, things like that. You have more options for pipe type based on your conditions. So that's more things you need experience in to learn, because each one, they're all similar, but they have their little nuances that you only learn once you start installing them. So I think those are both really important. And then something else based on, you know, talking about this partnership thing, it can be valuable if you can bring the contractor on with some like pre-construction services, even during design, to give some input on that, so that by the time you have your full design package to go out to bid, there's already been some coordination up front. So you're not going to get any kind of surprises when we move into construction. So we've had success with that on some situations where the contractor's been brought on to do like a logistics review or things along those lines, just to smooth things out during construction.
Right. No, that's very good point. Michele, any thoughts on kind of what you're looking for in a contractor?
So all those, as well as, you know, being able to weld the pipe. You know, we've had, you know, strict welding requirements on our contracts. We also have how many projects have you done in the last 5 years that are in similar size and scope? Because if you've done 5-inch pipe and we want you to do a 24-inch pipe, that's not similar in size and scope. That's a whole different animal, you know, laying 24-inch pipe as well as, you know, than 5-inch pipe. And same thing with tunneling. Do you have tunneling experience? That's super important to us, because a lot of times we have to tunnel, because to get underneath all the utilities, the only way to do that is via tunneling. So, and then the last thing is, you know, what is their record on their completion time? Are they on time, and are they on budget? You know, what does that look like for that particular contractor? But everything else that they said was spot on.
Right. You know, one thing that we've added to what we're looking for is experience with the Inflation Reduction Act, because actually the contractor now has a bunch of requirements in terms of apprenticeship or made in the USA or, wage, what they're going to pay. So all of a sudden now we're asking the contractor to look at the Inflation Reduction Act, understand the regulation, help make sure that we can get the most amount of credit we could possibly get, which is in their control, but ultimately we, get that benefit. So that's a new thing we're adding to kind of how we're looking at contractors, which we never really did before. So
Ruthie, Laura did enter one question. I don't know, Laura, if you want to read it or if you want me to, but.
Oh, good. Okay.
She said there are a lot of considerations in evaluating a new distribution system. Does anybody on the panel have a basic written checklist they could share with the group to help institutions start the process? So.
I don't have a checklist per se. I think from this we could create a checklist.
Right. So we have a general checklist. I don't think it's particular to this. When we each phase of the project at Tufts, we have kind of an owner project requirement, and then we sort of follow that through to our projects. But I think you're right, Ximena, right? Like a lot of the questions that we talked about today, we're trying to get the information, we're trying to move it earlier in the process so that the client, the owner, the institution knows what to ask of themselves and their consultants before they even put pen to paper, right? Before they even think about where it's going to go or what it's going to cost. I think one of the things you said in the very beginning was, what's your goal, right? Is your goal to do this as quickly as possible? Is your goal to reduce your carbon as much as possible? Is your goal to do this in the 3 months when the students aren't on campus? Good luck with that. But some campuses, live that way. And so I think a lot of those questions will help create that checklist. So maybe we can work on that, Tanya, and share it. I don't think we have it now, but it'd be fun to create that. Any other questions from the audience? Nope. I have one last one that I wanted to ask the group. When the engineer is laying out the distribution system, are there specific regulations you have to follow, right? Like, can it, it only has a certain amount of bends, it has to be a certain size, what's the regulation that the engineer is following? I'm assuming there must be one, if not a couple, but I just wanted to hear, maybe Elizabeth, you can help us.
Sure. So there's a lot, and it depends on which utility you're installing and what kind of material you're installing, where you're putting it in. So, for instance, for a lot of mechanical piping, Michele actually mentioned it earlier, B31.1 is the code for kind of thermal stresses and expansion. So any sort of hot or chilled water piping, looking at how the pipe's going to grow or shrink when it's filled with hot or cold liquid, that's going to impact the amount of bends you need, or where you can anchor it based on how it's going to move once it's actually up and operating and changing from a cold to a hot or vice versa situation. If you're putting in an underground deck bank, there's NEC codes governing the amount of bends you can have to be able to pull the cable through it and how often you need to space manholes. There's local codes normally governing how close water and sewer lines can be together and how close those can be to hot utilities. There's federal erosion sediment control plans. If you're over an acre, you need to do permitting for that as well. So it's going to be really dependent on where you are, how much you're disturbing, what utility you're putting in the ground. But there are plenty of codes to be used as you're,
when you're doing a distribution system, right? It's not just the pipe coat size. It's so much more. It's such a complicated.
It's the bends and what you're moving around and what dirt you're digging up to get to it. So
so those are the questions I had for our group. I don't know, Tanya, if there's any other questions from the audience. Otherwise, we can get right to 5 o'clock.
Yeah, there were not any other questions at this point, but we appreciate all that you guys have been talking about.
Yeah, sure. Well, glad to do it. Thanks for allowing us the opportunity to have the conversation.
Welcome. Look forward to doing it again for sure in different venues, possibly at a conference There's a lot of really good information that was shared, so I'd like to share it additionally. And we did record this, and we will be posting it for people that missed the conversation, and others can download it after the fact also.
Great. Okay.
Hey, thanks for having us.
Yeah,
Thank
thank
you.
you.
Thank
Appreciate
you.
it. Thank you.
Thank you to everybody who participated on the panel and everybody who joined us today. Really appreciate it. And like I said, if you have any ideas or suggestions that you'd like to see DEWI implement, let Janae or myself know. And you guys have a great evening. And we'll see you in next month in Florida.
Thank you.
Thank you.
Okay.
Thanks.
Bye.
Bye-bye.
Bye.